Welcome you all to Principles of Organic Synthesis. So far, we had 18 lectures where we studied aliphatic carbon-carbon bond formation, aliphatic carbon-nitrogen bond formation, aromatic electrophilic substitution and aromatic nucleophilic substitution reaction. Today we will start the new topic, aromatic diazonium salts. In this topic too we will have 3 lectures. In this lecture we will study the formation of diazonium salts and their reactions. As all of you know very well, when you treat primary amine, the nitrous acid and acid medium, you will be able to form diazonium salt. An example shown here. So, in this reaction, the reaction of aniline with the sodium nitrite, the presence of HCl shown. The temperature of this reaction is very crucial. Since this salt is less stable, you have to carry out the reaction below 5 degrees Celsius. If you compare the stability of the aliphatic and aromatic diazonium salt, the aliphatic diazonium salt is very less stable. They can undergo decomposition into carbocation. On the other hand, aromatic diazonium salt is somewhat stable. This is a common method we use to prepare the aromatic diazonium salt. In this, nitrosonium ion is an electrophile. These are some of the other methods to make the diazonium salt. And in this reaction of aniline, the N2O3 nitric acid and aqueous medium shown, you can try to make this diazonium salt. Similarly, you can also use in the place of N2O3, you can also use Na2S2O5 and you can make the diazonium salt. This is a common method we use to prepare the diazonium salt. As just I mentioned, if you compare with aliphatic, aromatic diazonium salts is reasonably stable. Usually this reaction, once you make the diazonium salt, we carry out further reaction medium. If you want to isolate the diazonium salt, what you have to do? You have to try to react with fluoroboric acid. For example, once we have this salt, you can try to react with and you will be able to form this tetrafluoroborate. This is very stable salt. You can try to isolate and keep at room temperature. You can also try to react with organic nitrite in aqueous in acetic acid medium. You can try to make the salt. You can precipitate from the ether. But this, if you want to isolate, you can make the once you make the diazonium chloride, you can try to react with fluoroboric acid. You will be able to get the tetrafluoroborate salt. You can try to isolate, you can store it. When you go for the effect of substituent, the formation of diazonium salt, when you have electron withdrawing group like nitro group, the reaction is very slow, it is not effective. So, I tell you the reason the next slide. Now, let us look at the reaction pathway for the formation of the diazonium salt from aniline using sodium nitrite in the presence of hydrochloric acid. So, you have to take sodium nitrite in aqueous medium, you dissolve in water. Once if you take this one, you have to add to a solution where you have hydrochloric acid and amine. So, this can undergo reaction with HCl. So, to give HNO2. Once you have this one, this can undergo protonation, since you carry out the reaction acidic medium. You have this species which can react, since you have this can react as shown here. To give N2O3. This can lose proton, then you will have once you form this one, this can readily undergo reaction with amine. If you write aniline as an example, this can now react and you will be able to get the addition product. This can lose a proton. You will be able to have proton transfer can lead to the formation of this species. Once you form this one, this can exist in cis trans form. If you form this one, since you carry out the reaction acidic medium, protonation of this can lead to the formation of this. Once you form this one, now this can lose water molecule. You will be able to have, since you carry out the reaction in acid medium, you will be able to form this salt. You can make the diazonium chloride as the product. First, the sodium nitrite reacts with the hydrochloric acid, then you will be able to form the nitrous acid. Once you form this, which can undergo protonation, followed by, as you can see here, for substitution, you get this N2O3. This also can lose water molecule. You can also make nitrosonium ion. Once you form this one, whether nitrosonium ion or this one, which can readily undergo reaction with amine, which acts as a nucleophile, which is electrophile, you get this addition product. Once we have this one, this can convert into this. This can exist mixture of geometrical isomers. Once you form this one, now this can undergo protonation to give this, that can lose water molecule. You get the diazonium salt as the product. If you look at the properties of diazonium salt, they are ionic in nature, they are water soluble, they are crystalline solids. If you look at the benzene diazonium chloride is soluble in water, but reacts with only when warmed. This is stable in water. So, soluble in water when the reaction takes place when you heat the solution. So, it will lead to the formation of phenol, we will see later. So, benzene diazonium fluoroporate is not soluble in water and pretty stable at room temperature. That is just I have mentioned, when you have this benzene diazonium chloride, you can try to react with fluoroboric acid, you will be able to form the tetrafluoroborate, which is a stable compound at room temperature. Now, let us look at, just I have mentioned, effect of substituent in the formation of diazonium salt. If electron withdrawing group is present in the aromatic ring, that amine is difficult to undergo reaction. This is because, now let us take this an example. Let us take this nitroaniline as example. Since this electron withdrawing group, the lone pair present in the nitrogen can undergo delocalization as shown here. It can exist like this. So, the nucleophilicity of the amine is reduced when you have the strong electron withdrawing group like nitro group. It is difficult to make the diazonium salt. However, you can make diazonium salt using weak acid like acetic acid by modifying the reaction conditions. Normal conditions it does not work. For example, if you want to make diazonium salt in hydrochloric acid, it does not work. This is because the nucleophilicity of nitrogen is reduced due to the electron withdrawing nature of the substituent. Just we have seen how you can make the diazonium salt. What you have to do, you have to dissolve the sodium nitrite, which is commercially available in water. Once you make the aqueous sodium nitrite, then you have to add to your solution where you have your amine and hydrochloric acid by controlling the reaction temperature. You have to add until you have excess nitrous acid. That is very important. The reaction is to be carried out in acid medium. Once the reaction is completed, you have sufficient nitrous acid, then you will be able to complete the reaction. Now, let us see the reaction of the diazonium salt. There are three types of reactions can readily take place. The first one is, if you have nucleophile, for example, you have a diazonium salt, you have a weak anion. See, if you have Cl minus is very strong. On the other hand, if you have a weak anion like CH3CO minus, so what can happen if you have a strong nucleophile which can undergo addition reaction with this one, then you will be able to get the addition product. For example, in this case, when you react with cyanide ion, it can undergo addition reaction with this salt, then you will be able to get the diazo compound. As just I mentioned, it can exist as a mixture of isomers. A mixture of geometrical isomers, and similarly here is shown. You can also try to react with the hydroxide ion. It can undergo addition reaction and you will be able to get this compound. You have to make sure that the reaction is acidic in nature. If you basic in nature, you will have this species. Once we have this one, now let us look at So, here an example shown, if you have the strong nucleophile which can undergo addition reaction with this nitrogen, you will be able to addition product. We have seen two examples. First example involves the reaction of cyanide ion which can undergo addition, you will get this compound diisocyanide, and the other one you can this example, the reaction of hydroxide ion shown which can also undergo addition reaction with this salt, then you will be able to get this hydroxide. In the presence of base, you can convert into this anion species. So, on the other hand, if you heat the diazonium salt, so just whatever we have seen the addition reaction to diazonium salt, where you have strong nucleophile comparing to a counter anion, the reaction carried out is less temperature. On the other hand, you have the diazonium salt, when you heat it, it can undergo decomposition to give the aryl cation plus. So, when you heat it, it can lose nitrogen, you will be able to form the aryl cation. Once if you have the aryl cation which can be reacted with the nucleophile, here an example shown, you can try to react with the Br minus and it can undergo nucleophilic substitution. What you do here in this case, the diazonium salt is when you warm up, when you heat, it lose nitrogen molecule, you make a aryl carbocation. Once you form the aryl carbocation which can readily undergo reaction with the nucleophile, in this case the reaction of Br minus shown, you will get the bromobenzene as the product. Another example shown here, and just we have seen when you heat the diazonium salt which can lose nitrogen and you can generate the aryl carbocation. Once you form this one, this also can undergo reaction with the hydroxide ion and water present the reaction medium. Therefore, whenever you heat the diazonium salt, then it can lose nitrogen, you will be able to form a carbocation which can be readily reacted with the nucleophile via SN1 pathway. The other type of, here an example shown for this one. So, here the reaction of diazonium salt with water is shown. When you heat it, and you will be able to get phenol as the product, and this is the reaction pathway. When you heat it, you lose, you make the carbocation which can undergo reaction with the water, and then you lose the proton, you will be able to get phenol as the product. Normally, if you try to remember, phenol is made if you have the sulfonic acid. For example, you have this sulfonic acid, you can convert into salt. This one, when you heat with sodium hydroxide, then you will be able to get So, this is the common method if you want to make phenol, and usually we make from the sulfonic acid. When you react with sodium hydroxide, you will be able to get phenol. So, however, where you have problem to prepare phenol using this method, you can try to convert, if you have the amine, you can convert into diazonium salt, you can try to react with water under heating, then you will be able to form the corresponding phenol derivative as the product. So far we have seen two type of reaction. First one, you have the diazonium salt, you do not heat at you just carry out the reaction with the nucleophile. When you have the weak counter anion which can readily undergo addition reaction, we have seen two examples. One is the reaction with cyanide ion, another example with the hydroxide ion, you can undergo addition reaction, you get the addition product. On the other hand, if you heat the diazonium salt, you will lose nitrogen molecule, you will be able to generate the aryl carbocation which can readily undergo reaction with nucleophile. For example, when you heat in water, you can convert into phenol as the product. Here the third type of reaction shown. So, in this reaction, if you react the diazonium salt with the copper 1 chloride, and you will be able to form a radical. Here a single electron transfer reduction takes place. Copper can give 1 electron to this, and you will convert into the diazonium salt into this phenyl radical, and you lose nitrogen molecule, and where copper 1 is oxidized to copper 2. So, once you form this one, now this can convert into the chlorobenzene. And similarly, here an example shown, in place of copper chloride, you can also use copper bromide, and you can get bromobenzene as the product. This is one of the ways. Suppose if you have aniline derivative, you can try to make diazonium salt, which can be readily reacted with the copper halide, then you will be able to get the corresponding halo compound. This reaction is good if you want to make chloro or bromobenzene, you can use this approach. This is known as Sandmeyer reaction. We are going to look at in detail later. So far we have seen three types of reaction. First reaction what we have seen, just we take diazonium salt, suppose if you have a weak counter anion, you can try to react with a strong nucleophile like cyanide ion, because it can undergo addition reaction, then you will be able to get the diazo compound. We have seen two examples, one for the reaction of cyanide ion, another one is hydroxide ion. You can also try to react similar way. If you have the diazonium salt, you can add variety of nucleophile. For example, so you can add phenoxide. So which also can undergo addition reaction, then you will be able to get the addition product. For example, in this case, so this can convert into similarly, if you have aniline, which also can undergo reaction. For example, if you have this one, this also can undergo addition reaction, as we have seen, and you will be able to get it can convert into so therefore, whenever you carry out the addition reaction, you have to make the reaction medium acidic. If you don't make acidic, for example, if you have this anion like this, it can undergo phenol. Suppose if we have the phenol, then there is no problem, it cannot undergo reaction. On the other hand, the reaction is, for example, let us look at this one here, and the reaction medium should be acidic. If it is not acidic, and if you convert this phenol to the phenoxide in basic medium, this can undergo reaction with this diazonium salt. So then you will not be able to make phenol. Therefore, you have to make the reaction medium acidic. So as soon as you form a phenoxide, that is prone to undergo addition reaction with this diazonium salt, you will get the addition product. So, therefore, you have to control the pH of the reaction medium. So far we have seen three types of reaction. First one we have seen, you take diazonium salt, and if your counter anion is weak nucleophile, then you can add strong nucleophile like cyanide ion, which can undergo addition reaction, or phenoxide also can undergo addition reaction with this nitrogen, you get the addition product, you will get mixture of geometrical isomers. Then we have seen the SN1 pathway, where if you have the diazonium salt, you can try to heat, then you can lose nitrogen molecule, where you generate the aryl carbocation. That carbocation, if you carry out the reaction medium, it can undergo addition reaction with the nucleophile, you get addition product. Then we have seen single electron transfer reduction reaction, where if, for example, if you have the diazonium salt, for example, if when you react with the copper 1 chloride, it can reduce the diazonium salt into the corresponding phenyl radical and nitrogen gas, and where the copper 1 is converted into copper 2. So, that can further now transfer the halogen. This way you can make chloro and bromobenzene. Here an example shown for. Now, let us look at the replacement of nitrogen. For example, if you take the diazonium salt, and the diazonium salt can be converted into halobenzene. For in this case, for example, if you want to make a fluorobenzene, what you have to do? You have to make the diazonium salt, as just we have seen, you have to react aniline, aqueous sodium nitrite, HCl, you make diazonium chloride. Once you form this one, this can be reacted with fluoroboric acid. Once if you react this one, you will be able to form the salt, which is stable. You can also isolate. Once if you have this salt, when you heat, the salt can decompose, and you will be able to form the carbocation. So, once you form this one, it can transfer, you will be able to get fluorobenzene. And see, if you want to make fluorobenzene, this is one of the effective synthetic route. If you have aniline, you can make the diazonium salt, then you convert into tetrafluoroborate, which is stable salt. Once if you heat this one, it can convert into fluorobenzene. Recently, there are also progress has been made. You can also, instead of that, you can make this salt. This also, when you heat, as just we have seen, it can convert into fluorobenzene. So, if you want to make fluorobenzene, this is one of the effective synthetic route, and you can try to heat, then you make this aryl carbocation. Once you form this one, which can readily undergo reaction, then you will be able to get this compound. This goes via SN1 pathway. The next example, just we have seen, if you want to make fluorobenzene, you can make tetrafluoroborate. Then when you heat it, you can convert into fluorobenzene. On the other hand, if you want to make chloro or bromobenzene, the reaction is not successful because it undergoes decomposition. When you heat the diazonium salt, it can undergo decomposition. So, therefore, the one of the effective synthetic route to convert diazonium salt into chlorobenzene is so you can try to react with the copper 1 chloride in hydrochloric acid medium. When you heat it and you form a complex which can undergo decomposition into aryl chloride as the product. If you compare the previous one, here just you heat this one, you get this compound, and when you do similar way, and in the case of diazonium chloride, it undergoes decomposition, you do not get good yield. So when you add copper 1 chloride, the reaction medium, you will be able to form a complex which leads to the formation of the aryl chloride as a product in good yield. This is known as Sand-Meyer reaction. When you look at the reaction pathway, as we have seen earlier, and you can make the diazonium chloride. For example, in this case, the reaction of 4-methyl-aniline shown. When you react with sodium nitrite, as we have seen earlier, HCl, and you will be able to form the diazonium salt. Once you form this one, when you react this in hydrochloric acid medium and the copper 1 chloride, it undergoes reaction, single electron transfer process, copper 1 gives 1 electron to that. So, it is converted into phenyl radical, converted into aryl radical. Once if you have this radical, then copper 1 is converted into copper 2 chloride. So, when you have the diazonium salt react with the copper 1 chloride, it is converted into the aryl radical, and copper 1 is converted into copper 2 chloride, and you lose the nitrogen molecule. Once you form this one, now this copper 2 can undergo reaction with this radical intermediate to give copper 3 species, which can give the product by reductive elimination. This is copper 3. You get the aryl chloride and copper 1 chloride. On the other hand, this radical also can react and you will be able to get this product where you lose copper 1 chloride. So, there are two possibilities there. So, once you form the aryl radical, it can directly react with the copper 2 chloride as shown here. You can convert into the aryl chloride. Alternatively, it can also undergo reaction with the copper 2 chloride, you form copper 3 intermediate. Once you form this one, this can give the product by reductive elimination where you generate copper 1 chloride. So, this reaction involves, as we have seen, single electron transfer process. Copper gives 1 electron to this molecule, it reduces into phenyl radical and you lose the nitrogen molecule where copper is oxidized to copper 2 chloride. Once you form this one, this radical can further react with this, you will be able to form the chlorobenzene as the product. You can use the same method for the preparation of bromobenzene also. It can also in place of copper 1 chloride, you can use copper 1 bromide and you will be able to make the corresponding bromo derivative. You can use hydrogen bromide in place of hydrochloric acid, you will get the bromo derivative as the product. However, when you want to make iodobenzene, for example, if you want to make iodobenzene and you can use potassium iodide, you do not need copper 1 iodide there, because this I minus has reducing potential similar to copper 1. So, you do not need whenever you want to do convert in the diazonium salt into the corresponding aryl iodide, you do not need copper 1 iodide, because this I minus itself is it has reducing potential which is similar to copper 1 iodide. Therefore, if you want to make, for example, iodobenzene, what you can do, you can take the diazonium salt once you have this one, you can try to react with potassium iodide. Let me write I minus. So, once this can now undergo reaction to phenyl radical as just we have seen, plus I dot plus N2. So, if when you use I minus, it will be converted into I dot and phenyl radical. Now, the phenyl radical can react. We have I 2, it can react, you will be able to have iodobenzene plus I dot. So, I dot, this I minus can give radical anion. Once we have this one, this also can react with your diazonium salt. To give aryl radical plus nitrogen plus I 2. So, if you want to make iodobenzene, you can try to directly react with potassium iodide, for example, and you will be able to do the iodination. You can try to replace the N2 with I, then you will be able to make iodobenzene as the product in good yield. So far, we have seen the replacement by halogen. We have seen if you want to make fluorobenzene, what you have to do? You have to convert the diazonium chloride into tetrafluoroborate, then you have heat it, and then you will be able to make the fluorobenzene. The reaction goes via SN1 pathway. Then we have seen if you want to make chloro or bromobenzene, you can use copper 1 chloride as a reducing agent. It can reduce, it can give one electron to the diazonium salt, you will be able to form a radical. Once if you form the radical, then it can undergo reaction with the copper 2 halide that you generate in the reaction medium to give these corresponding chloro or bromo compound, which is known as Sand-Meyer reaction. When you go for the preparation of iodobenzene, and you can use simple potassium iodide, you do not need copper iodide, because the potassium iodide I minus has similar reduction potential as that of copper 1. Therefore, it can convert into diazonium salt into radical. That radical can react with I dot, then you will be able to get the iodobenzene as the product. You can also try to replace the nitrogen with cyano group. For example, here the formation of diazonium salt is shown here. Once you have this one, you can try to react with copper cyanide in aqueous potassium cyanide, then you will be able to get the corresponding cyano derivative. For example, here the reaction of this para-toluidine is given, you can get the para-toluenitrile in a good yield. You can also make the corresponding nitro derivative. For example, what you have to do, as we have seen here, you have to make the tetrafluoroborate. Once you make this salt, you can try to react with this aqueous sodium nitrite in the presence of copper powder, then you will be able to get the nitrobenzene. And as just we have seen that first you have to convert into diazonium salt. So, once you form this diazonium chloride, for example, this you can try to react with you get the tetrafluoroborate. Once we have this one, you can readily convert into the nitro derivative. That's as just we have seen, you can try to isolate and store it. So, whenever you need, you can try to react with aqueous nitrate in the presence of copper powder, you will be able to get the nitrobenzene as the product. So, this is the structure of this fluoroboric acid is it has tetrahedral structure. You have the hydrogen bonding. This structure of the fluoroboric acid. Once if you add this one, you will be able to get this tetrafluoroborate salt. This can be readily reacted with aqueous sodium nitrite. The presence of copper, you will be able to get nitrobenzene as a product. This, as you know, is very important compound be used for as precursor to make variety of nitro derivatives. Here some examples are shown. The first one, if you look at here, the reaction of this aniline derivative with HNO2 and potassium iodide is shown, which can be converted into the iodide derivative as we have seen. And when you have the aniline and which can be reacted with sodium nitrite and HCl, and you will be able to form the diazonium salt. Let me write once you form this one, as just we have seen, you can try to react with potassium iodide, which can undergo reaction through radical pathway, and you will get the aryl iodide. So, once you form this one, you can see the yield is very good. This can be coupled using copper in DMF. This is called Ullmann coupling, and you can try to react with the copper iodide, then you will be able to form the CC coupling. Once you form this one, and this can be converted into diamino derivative by reduction of the nitro group. And once you form this one, this as just we have seen, then again the amino group can be converted into diazonium salt, which can be further reacted with the potassium iodide, and you will be able to get the diioda compound, which can be further utilized for various applications. You can see here how the diazonium salt chemistry plays very important role to construct highly functionalized molecule. And if you look at here, you have the ether group, nitro group. Selectively, you can try to convert the amino group into the corresponding iodide derivative. Once you form this one, which can be coupled with another two molecule can undergo reaction, this is called Ullmann coupling, then you will be able to get the CC coupled product, which can be further reduced into the diamino derivative. The diamino derivative can be further converted into diazonium salt, which can be further reacted with potassium iodide, will be able to get the diode derivative as the product. The next example involves the reaction of nitrous acid this aniline derivative, you make the diazonium salt. Once you form this one, you can try to react with the copper cyanide, as we have seen earlier. Sandmeyer reaction, you will be able to get the cyanide derivative, and this reaction involves the transformation of this NH2 into bromo derivative. As we have seen, the nitrous, you can try to react the aniline derivative with this nitrous acid. In the presence of HBr, you can make the corresponding diazonium salt. Once you form the diazonium salt, which can be readily reacted with the copper 1 bromide Sandmeyer reaction through radical pathway, as we have seen, the diazonium salt will be converted into the radical. Once you form the radical, that radical can react with the copper 2 bromide, and you will be able to get the bromo derivative, where you will be able to regenerate copper 1 bromide to complete the reaction pathway. These are some of the example you can see here. The Sandmeyer reaction plays a very important role in synthetic chemistry. If you want to convert the amino group into the halo functional group, for example bromo, and you can use the Sandmeyer reaction. And similarly, if you want to convert into NH2 group into the corresponding cyano group, you can use copper cyanide. You can convert into diazonium salt, which can be further reacted with the copper 1 cyanide, and you will be able to get the cyano derivative. And if you want to make iodide derivative, you do not need copper 1 iodide. Straight away you can try to react with potassium iodide. You will be able to transform the diazonium salt into the corresponding iodide derivative. This reaction also involves a radical pathway. The next example involves the reaction of diazonium salt into the radical. As we have seen, if you have the copper 1, you will be able to form the radical by singular electron transfer process. Once you form the radical, this radical can be further reacted with, for example, in this case hypophosphorus acid. You will be able to get benzene as the product. So, when you go for the reaction mechanism, in this reaction, as we have seen, the copper 1 can convert into diazonium salt into the aryl radical. Copper 1 oxidized to copper 2. Once you form the aryl radical, this aryl radical can react with this hypophosphorus acid, and you will be able to form this radical. This, in the presence of water, can convert into so if you have the diazonium salt, you can try to react with the copper 1 iodide to give the aryl radical. That aryl radical can be further reacted with the hypophosphorus acid to convert into the aryl derivative. As you can see here, for example, when you have the benzene diazonium chloride and you can try to react with the copper 1 iodide, you get the phenyl radical. This can be further reacted with hypophosphorus acid, you will get the benzene as the product. Now, let us look at application of this reaction. For example, if you have the toluene, you can convert into this bromo derivative using this approach. So, you can, for example, when you do the nitration, as we have seen earlier, you will be able to form this nitro derivative. Once you form this one, this can be reduced. If you reduce the nitro group, you will be able to have this aniline derivative, which can be reacted with acetic anhydride in the presence of base. You can do the acylation, you will be able to get this amide. Once we have this one, when you do the bromination, we look at this one, this also electron pronating, but this also, this is more effective comparing to this. In this case, this substituent dominant comparing to therefore, the bromination will take place at the ortho position. So, once you form this one, now you can do the hydrolysis. When you do the base hydrolysis, you will be able to get the aniline derivative. Once you form this one, as just we have seen, you can convert this into diazonium salt, and which can be now reacted with the hypophosphorus acid in the presence of copper halide. When you add copper halide, you will be able to form the radical, which can be reacted with this hypophosphorus acid to give this aryl bromide as the product. And if you look at here, this is very useful reaction. For example, if you have the toluene, it can be converted into when you do the bromination, always the bromination will take place and para and ortho position. However, using this approach, for example, first to do the nitration, it takes place in the para position. Once you form the para nitro toluene, then it can be reduced into this amine derivative. Once you have this one, you can try to react with acetic anhydride, you can make this amide derivative, which can now, when you do the nitration, which is a strong directing group, it can direct, the bromination takes place the ortho position. After the bromination, you can do the base hydrolysis, you can remove the acetyl group and you can get this free NH2. Once you have this one, you can try to make diazonium salt using nitrous acid and acidic medium. You can make diazonium salt, which can be reacted with copper iodide and followed by hypophosphorus acid. In this way, you will be able to get 3-bromotoluene as the product. Now, let us look at another example. You have here aniline. How will you convert into tribromobenzene? And this also very useful compound is when you have the aniline and you can try to do bromination. When you do the bromination, you will have this compound. Once you form the tribromoaniline, you can do, as we have seen, you can try to react with you can try to react with sodium nitrate followed by HCl, or you can try to react with nitrous acid, then you will be able to get the corresponding disodium salt. Once you form the salt, as just we have seen, you can try to react with the copper 1 and hypophosphorus acid. And you will be able to get the tribromobenzene as a product. So, this is very useful reaction. Suppose if you have the aniline derivative, you can try to introduce a functional group, you can try to remove the amine by making disodium salt followed by reaction with the copper halide and hypophosphorus acid as the reagent. The next example is Meerwin reaction, where as we have seen, and here also the disodium salt, when you react with copper chloride, for example, in this case, it can undergo reaction, you will be able to form the corresponding radical as the intermediate. Once you form the radical, this radical can undergo reaction. For example, in this case, the reaction of acrylonitrile is shown, which can undergo addition reaction. Then you will be able to have the addition product as is shown here. It can give one electron, it can convert into radical, and this is converted into copper 2 chloride. Once you form this one, which can undergo addition reaction, you will be able to have this intermediate. Once we have this intermediate, it can now react with copper 2, as we have seen earlier. You have the copper 3 by reductive elimination, and then you will be able to form copper 1 chloride, or it can also transfer so you will be able to get this compound. It depends upon the reaction conditions. On the other hand, suppose if you take a disodium salt, and when you react with copper 1, and you will be able to form the radical. This radical can also be reacted with styrene, for example, and you will be able to have this radical intermediate. This radical can now also lose hydrogen, you can convert into stilbene. Depends upon the reaction conditions, you can also do the addition reaction. So, now if you try to remember these reactions, and see, you have here radical, this radical also can undergo dimerization, does not happen here. This is because the 2-phenyl radical can dimerize, you can get the homocoupled product, but here if you look at this substrate, here the radical can undergo addition reaction. You generate the radical, that radical, whatever radical you generate, that radical can be stabilized by this cyano group. This is the main reason how the Meerwin reaction takes place. On the other hand, if you remember earlier, if you have the radical, this radical also can undergo reaction with, for example, in this case copper 2 chloride, you will get the chlorobenzene. We have seen the Sandman reaction. Whenever you have the disodium salt, when you try to react with the copper 1 chloride, you will be able to have the radical intermediate copper 2 chloride. That copper 2 chloride again reacts with the radical intermediate, then you get the chlorobenzene or aryl chloride as a product, where you regenerate the copper 1 chloride. But in this case, if you look at here, this copper 2 chloride does not react with this radical. Instead of the radical undergoes addition reaction with this acrylonitrile or styrene, you form a radical. That radical is stabilized by the electron withdrawing nature of this cyano group as well as the aryl group, where it can stabilize through the delocalization. Therefore, here the addition reaction is favored and you get this radical. As soon as you form the phenyl radical which undergoes addition reaction with the acrylonitrile or styrene, and we can give the secondary radical, this radical alkyl radical which is stabilized by this cyano group or the aryl group. Was as soon as you have the radical that can now react with the copper 2 chloride, then you will be able to get the addition product. Now, let us look at this example, and you can also in place of copper 1 chloride you can also use titanium 3. For example, you have this diazonium chloride, you can try to react with the titanium 3. So, this also can give one electron, it will be converted into titanium 4 and you will be able to have the radical. Once you form the radical, this radical now can react. For example, in this case you have taken ketone, methylvinyl ketone, it can undergo addition reaction and you will be able to have radical. This can now react with another molecule of titanium 3, it can reduce, can convert into anion. Once we have the anion, so it can undergo protonation. You can get the addition product. So, if you look at here, it has also broad applications. Whenever you have the alkene, it has the electron withdrawing group or phenyl group, and which can be readily reacted with the diazonium salt. When you react the diazonium salt with copper 1, then or titanium 3, you will be able to form the radical intermediate. That radical can readily undergo addition reaction with this alkene, which is having the electron withdrawing group. You have the addition product. Depends upon the reaction conditions, you can convert into the halo substrate. In summary, in this lecture we have seen the preparation of diazonium salt. The reaction conditions crucial for the formation of diazonium salt. When you have the primary amine, when you react with nitrous acid and acid medium, you can convert into the corresponding diazonium salt. Both aliphatic and aromatic amines can be readily reacted. However, if you compare the stability of the diazonium salt, aromatic diazonium salt is more stable comparing to aliphatic diazonium salts. Usually these salts are reacted in reaction medium and to give the corresponding product. If you want to isolate the diazonium salt, for example, in case of aromatic diazonium salt, you can try to react with the fluoroboric acid and you will be able to get the tetrafluoroborate, which is stable at the room temperature. You can try to isolate and you can use for various applications. Then we have seen that the effect of substituent in the formation of diazonium salt. For example, if you have the electron withdrawing group like nitro group, the reaction is less effective. Therefore, you have to change the reaction conditions. You have to use weak acid like acetic acid to pursue the reaction. This is because the lone pair present in the nitrogen, the amine which undergoes a delocalization due to the electron withdrawing nature of the nitro group, the reaction is slowed. Then we have seen the possible types of reactions in the case of diazonium salt. There are 3 types of reactions possible. The first one, you can try to, if your anion is weak nucleophile, you can try to react with a strong nucleophile like cyanide ion, which can undergo addition reaction with the nitrogen. You will be able to get the addition product, you will get the geometrical isomers. We have seen some example, addition of cyanide ion, addition of hydroxide ion and phenoxide ion. We have seen they can readily undergo addition reaction. On the other hand, if you heat the salt, it can lose nitrogen molecule, you will be able to generate the carbocation. the phenyl carbocation which can undergo reaction with the nucleophile via SN1 pathway. We have seen some examples. Then we have seen if you can also reduce the diaphanium salt, you can try to react, for example, with copper 1 halide. You can, by single electron transfer process, you can convert into aryl radical, and where the copper 1 is oxidized to copper 2, then it can convert into the corresponding halo substrate. We have seen, for example, if you want to make aryl chloride, aryl bromide, aryl cyanide, you can use the copper 1 halide, for example, copper 1 chloride, copper 1 bromide, copper 1 cyanide, to make the corresponding derivatives. In case of iodide derivative, you don't need it, just you can try to react with potassium iodide. This is because I minus has similar reduction potential as that of copper 1 iodide. It itself can initiate the reaction. All these reactions involve radical pathway. Once you form the radical, that radical undergoes reaction. For example, you can react with the copper 2 chloride, you can give the chlorobenzene. Similarly, it can react with the copper 2 bromide, you can get the corresponding bromobenzene derivative. Similarly, in the case of iodobenzene also, you have the iodine radical which can undergo reaction with the phenyl radical, you get the iodobenzene as the product. Then we have seen the formation of fluorobenzene. This can be done when you heat. For example, you have the tetrafluoroborate. When you heat it, you generate the carbocation which can react with tetrafluoroborate. You can make the fluorobenzene. We have seen an example. Then we have seen the Meermin reaction, where if you have the radical, the reaction condition, as just we have seen, is crucial. The nature of the substrate also plays very important role. Here also what happens, if you have the diazonium salt, when you react with the copper 1 and you can generate the radical, this radical now it undergoes addition reaction. For example, if you have the alkene, it can undergo addition reaction, you will be able to generate the secondary radical. That radical can be stabilized by the substituent. This is responsible for the addition reaction, where we have seen some example. Acrylonitrile and styrene we have seen, it can undergo addition reaction. You will be able to, depends upon nature of the reaction conditions, you can get the addition product. But in this case, we also have seen one example where you can, in the place of copper 1, you can also use titanium 3, you can carry out the addition reaction, and you will be able to get the addition product. So as you can see here, the preparation of diazonium salt is you can carry out in the laboratory. It's very easy to prepare. You can use for various applications. With this, we conclude this lecture. Thank you very much.